Bonjour and good morning. Welcome to WASA Distance Education and PLAR Math. And this is our second class in week 3. So just a reminder that for this week only, the PLAR Math was broadcast yesterday and today. So that's our 2 classes this week. And the PLAR Science will be broadcast tomorrow and Thursday. But that's only for this week because of due to illness and appointments. So we've switched around a little bit. So next week we'll be back to the regular PLAR Science Monday, Wednesday, and PLAR Math Tuesday, Thursday. So just keep that in mind for calling in for classes. 2 ways to participate in classes. So you can call into our studio using the radio, or you can join via Zoom. The instructions for joining the Zoom class are in your study guide. If you don't have a study guide, you can contact me or your DEC. All PLAR English students are welcome to attend classes, so you don't have to be signed up for radio Zoom classes. You can, if you're signed up for IL, you can still attend the classes if it's convenient for you. To contact me, you can use email, phone, or send a message on Facebook, and all of my contact information is on the cover page of the study guide as well as every lesson. Students who were working on the PLAR from Term 1A or prior to that, even over the summer, can keep working on the key questions or the culminating activity and continue to submit your work to your teacher. The recorded classes from last term and from last year are still available on the WASA YouTube channel. So if you are working with us in the classes, then you would, I'm not quite sure what I was going to say here. I've lost my train of thought. Anyway, you can still keep working on whatever it is you're working. That's what I meant to say. You are not withdrawn at the end of the term. So you just keep working. You sign up once during the year for WASA, for PLAR, sorry. And then once you're signed up and you're in the PLAR program for the year, then you keep working until the end of June when we finish our radio classes for the summer. And then if you want to do work on your PLAR over the summer, you need to sign up for the summer. And then the following September, you need to sign up for the school year again. So you only sign up once during the school year for PLAR. And again, once you're in, you're in. So to find the recorded classes on YouTube, go to YouTube and search WASA Distance Education Center. Once you do that, you will see our logo and our name. It's small compared to some of the other stuff that you see on the display on YouTube, but look carefully for it. You will see our WASA logo and then WASA Distance Education Center. So click on either the logo or the name, and our channel will open. Once you've opened our channel, you will see a random selection of classes that have been recorded since last September. To find the playlist for the subject that you're working on, click on playlists in the list under our school name. So home videos, podcasts, playlists, click on playlists. Once you do that, you will open a page with all of the subjects from last September. So some of them will be dated 2025, 2026. So those are the ones that we're teaching this year since Term 1A. And some will be dated 2024, 2025. So that's last year's classes. So for the PLAR English, the PLAR History, and the PLAR Geography, you would be looking at the 2025, 2026 playlists. For the Math and the Science, PLAR Math and PLAR Science, you would be looking at the 2024-2025 playlist because we just started. We're in week 3 right now. So we've only had 3 weeks of classes. So if you're ahead of where we're working, then you would go to last year's playlist to watch the classes. Once you've found the subject that you're working on, then click underneath the subject title and the year, click View Full Playlist. Once you click on that, then you will see all of the classes for the PLAR Math or the PLAR Science, whatever it is you're looking for. The classes are organized by lesson number and key questions. So Lesson 5, key questions 27 and 28. Lesson 5, key questions 24, 25, 26. So that way it's easier for you to find the lesson that you're working on or the key question that you're having trouble with. Okay. Another reminder for students that at the end of each term, WASA will have 2 student draws, one for students who earned a credit during the term and one for students who submitted work during the term. So for students who do all 5 lessons of, say, the PLAR math, your name will be entered into the work draw 5 times. If you also complete the culminating activity, submit and pass that, your name will be entered into the credit draw as well. So for everything you submit, if it's culminating activity, your name will go into the work draw once, and then for the credit draw once as well. So try to do as much as work as you can during the term to improve your chances of winning. Just a reminder to PLAR students, and this applies to PLAR students only, that all PLAR students have the option of writing the culminating activity, so that's the test, an open book test, instead of doing the lessons and key questions. So if you started with the lessons and you're finding the work really super easy, you're not having any trouble with it, then you can opt to do the culminating activity. So the culminating activity is the open book exam or test that you do after you finish the lessons. However, some students may have recently gotten out of school or are working in a job that requires them to use reading, writing, comprehension, or math skills or something like that. And so you've been practicing those skills and you feel confident that you could pass the culminating activity. You can skip the lessons and write the culminating. If you pass the culminating activity, then you get your missing credits for that subject and you can just move on to the next subject. If you're not successful with the culminating activity, then you will have to do the lessons and then complete another culminating activity at the end. So you'll go through the lessons, you'll complete the key questions and submit them, and then you will write a different culminating activity after that. So the lessons are designed to help you pass the culminating activity. Okay, so keep that in mind, but you do have the option to try a culminating activity before the lessons. Okay, if you do choose to do the lessons, there are 2 types of questions in the lessons, support questions and key questions. The support questions are the practice questions that you do before you do the key questions. So as you're going through the lesson, you'll read a section and then there will be a support question. Do the support question and then flip to the end of the lesson right before the key questions and you will find answers to support questions. So you can check your answers against the answers there. If you're doing really well, move on to the key questions. If you're struggling, you're not getting very many or any right answers, then you need to read the lesson again. You need to watch the classes on YouTube or you need to contact me for help. Okay, don't just skip over the support questions, go to the key questions. Because if you submit the key questions, you get them all wrong, I'm going to send it back to you, ask you to do what I just said, read everything again or watch the classes or contact me for help, and then you're going to have to fix the answers to the questions and send them back to me. So it's better to try the support questions first and see how you're doing before you do the key questions. So for submitting your work, the first way is to give it to your DEC, your DEC, and your DEC will send it out to us here in Sioux Lookout. If you don't have a DEC and or learning center in your community or your DEC is away, then you don't have to wait for them to come back. You can submit your own work. If you're submitting your own work, be sure to write your name on your work. So your full name on the first page and then initial all of the other pages. That way, if something gets mixed up with something else, we know how to sort it out, okay, because of the initials. So make sure that you identify your work. So if you are submitting your own work, one way to do it is if you have access to a scanner, scan and email your work to studentwork@nnec.on.ca. That's our student work email, and make sure you CC it to me. Or if you have access to a fax machine, you can fax it to our toll-free number. If that doesn't work for you, if you don't have a scanner or a fax machine, then you can use your smartphone. With your smartphone, you can take photos of your work or use the built-in scanner to scan your work and then email it to that same student work email and CC it to me. Or you can send your work using Facebook Messenger. So you can either take pictures of each page of your work, make sure it's a clear picture and send it to me with using Facebook Messenger, or if you know how to, you can use the built-in scanner on your phone and then scan everything as a single document and send it using Facebook Messenger as well. Okay. If you live in Sioux Lookout or the surrounding area, you can stop by Wausau on Front Street and drop off your work in our outdoor mailbox, which is located at the side of the building in the parking lot. Or you can just ring our doorbell and give your work to whoever answers the door. And another option is to use Google Docs. So complete your work using Google Docs and then send me the link to your work. Make sure the link is shareable. All right, so that now brings us to our review. So we started talking about fractions last day. We talked about what fractions are, and we talked about different types of fractions. So what is a fraction? So a fraction, if you think about a fraction of something, it's a part of something. It's a part of a whole. So a number that expresses equal parts of a whole object or a set of objects, so like a collection. So when we look at a fraction, there are two parts of a fraction. The top part is called the numerator, and that tells us how many fraction pieces you have. So how many parts you divided the whole into. Or sorry, how many parts you have, like how many parts are left or how many parts you took. The denominator, which is the number on the bottom of the fraction, so as I mentioned, D, if you're not sure numerator, denominator, you get them mixed up. Think of D down and the denominator is down at the bottom. So the denominator tells how many fraction pieces your whole is broken into. So how many pieces did you cut the watermelon into, or how many pieces did you cut the cake into? And then we have the fraction bar, or that little line that separates the numerator from the denominator. And that line, as we talked about before when we talked about division, represents division. So 1/2 or 1/2 means 1 divided by 2. So don't forget that, because we're going to be using that a lot later on when we get into algebra, as I mentioned before. So some key words when you're dealing with fraction: halves, thirds, fourths, fifths, sixths, sevenths, eighths, etc. So like I said, 1/2, that's a half. So don't say 1/2. Then we have 2/3. So the 3 on the bottom is thirds. 3/4. The 4 on the bottom is fourths. 4/7. The 7 on the bottom is sevenths. Okay, so think of fractions as, again, halves, thirds, fourths, fifths, sixths, sevenths, etc. Different ways to represent a fraction. I talked about this already. As a part of a group, so 4 circles. The bottom number, the denominator, tells us how many circles there are. One of the circles is red. So the top number, the numerator, tells us that 1/4 of the group is red. We can represent fractions on a number line. So from 0 to 1, that number line is divided into 4 equal pieces. 1/4 of the line is orange. A fraction bar, so we have a strip that is divided into 4 equal pieces. Each piece is 1/4 of the whole. And then a circle. One of the 4 pieces is red, so 1/4 or a quarter. Okay, the primary parts of a fraction, as I mentioned already, are the numerator and the denominator, the top and the bottom. Based on these, different types of fractions can be defined. So the types of fractions that we can have are, first of all, a unit fraction. So unit fractions are fractions with a numerator of 1. So 1/7, 1/2, 1/3, 1/4, 1/8, 1/10, 1/100th. They would all be unit fractions because the numerator is 1. Proper fractions are fractions in which the numerator is less than the denominator. To 2/7, 3/7 is also a proper fraction, 4/7, 5/7, 6/7. Okay, 7/7 is not a proper fraction. So anything where the numerator is smaller than the denominator is a proper fraction. Improper fractions are fractions in which the numerator is more than or equal to the denominator. So 5/3, 5 is bigger than 3, it's an improper fraction. 7/7, that's why I stopped at 6/7, because 7/7 is an improper fraction. 7/7 is the same thing as 1. So if the numerator and the denominator are equal, it's an improper fraction. Mixed fractions consist of a whole number, so in this case 8, and a proper fraction, 8 2/3. So we have a whole number plus a fraction. Like fractions are fractions with the same denominators. So 1/4 and 3/4. They have the same denominator, so they are called like fractions. Unlike fractions are the opposite. They have, well, I guess not the opposite, but they have different denominators. So 1/3 and 3/4, different denominators, they're unlike fractions. And equivalent fractions are fractions, we briefly talked about this last day, that have the same value after being simplified or reduced. So 6/4 and 12/8 represent the same amount, even though they look different. And we're going to talk a bit more about equivalent fractions today. So we'll look at that a little bit more. We also talked about how to convert a mixed fraction to an improper fraction. So a mixed fraction, remember, has a whole number and a proper fraction. Now when we start adding, subtracting, multiplying, and dividing fractions, we're going to have to change from from mixed fractions to improper fractions before we can add, subtract, multiply, or divide. So to change from a mixed fraction to an improper fraction, we multiply the whole number 2 by the denominator 5. So 2 times 5. Once we've done that, 2 times 5 is 10. Then we do the second part, which is to add the numerator, in this case 3. 10 plus 3 equals 13. Now, this is not your answer, 13, because that's not a fraction, that's a whole number. So in order to come up with an improper fraction, you take that 13 and you put it in the numerator's place in your new fraction, and the denominator stays the same as with your original fraction. So 2 3/5 is the same thing as 13/5. Like I said, don't forget to include that denominator. If you don't and you just leave it at 13, that's not correct. Okay, that's a completely different thing. 13 and 13/5 are not equal. So again, multiply whole number by denominator, 2 times 5 in this case, then add the numerator to that product, and then take the sum and put it over the original denominator. Okay, we also looked at doing the opposite, converting an improper fraction to a mixed fraction. And this is something you will have to do as well for your answers when we start adding, subtracting, multiplying, and dividing fractions. Okay, so your improper fraction, 15/7. So our numerator is 15. It's bigger than our denominator of 7. So to change from a mixed fraction, change from an improper fraction to a mixed fraction, we divide. So with the other way around, we multiplied and then added. For changing from an improper fraction to a mixed fraction, we divide numerator by denominator. So 15 divided by 7. You can use long division as well. 7 into 15. 7 times 2 will give me 14. 15 take away 14 will leave me with a remainder of 1. Okay, so how does that work? Well, that 2, the number of times that 7 divides into 15, becomes my whole number. Okay, because that's how many times 7 will divide evenly into 15. The remainder 1 becomes the numerator of my fraction, and the denominator stays the same. So I started with 15 sevenths. I'm going to end with sevenths, and in this case, 1/7. So 15 sevenths is the same as 2 and 1/7. Okay, so we're just converting from one to another. Okay, so that's what we did last day. So now we have finished everything on integers. We've looked at fractions. We've looked at, no, we haven't looked at reducing fractions, sorry. We looked at fractions. We looked at how to change fractions. And then last day we also looked briefly at equivalent fractions in your lesson on page 20. And then, sorry, support question number 7 on page 21. Sorry, it's a bit dry in this room. Okay, so what are equivalent fractions? So equivalent fractions are fractions with different numbers that represent the same part of a whole. They have different numerators and denominators, but their fractional values are the same. Okay, so the amount that they represent is the same, even though the fractions look different. So for example, think about the fraction a half. It means half of something. You can also say that 6/12 is half and that 50/100 is half. They represent the same part of the whole. These equivalent fractions contain different numbers, but they mean the same thing. So here we have more representations of a half. So you know what a half is. So we have a circle and we divide it into 2 equal pieces. We have 2 halves. So 1/2 is white, 1/2 is orange. We can also take that same circle and instead of dividing it into 2 equal pieces, we can divide it into 4 equal pieces. And we have 2 of those 4 pieces are orange, 2 are white, so we have 2/4. But if we look at the drawings, they're still representing the same thing. Okay, half of the circle. We can also divide that same circle into 6 equal pieces, and 3 of those pieces are orange, so 3/6, and it still represents a half. We can divide the circle into 8 equal pieces and have 4 of those pieces orange, and we're still representing half of the circle. So we've got 1/2, which is the same thing as 2/4, which is the same thing as 3/6, which is the same thing as 4/8, which is the same thing as 6/12 and 50/100. They all represent or equal 1/2. So 1/2, as you can see, this, as I mentioned earlier, is a unit fraction. And it's a unit fraction because the top number, the numerator, is 1. So once we get a fraction down so that the top, or even the bottom in some cases, is 1, that's lowest terms. You can't go any lower than that once you hit 1. Okay, so that fraction would be said to be reduced to lowest terms. So here's another couple of illustrations. We have a cake. 3 people have a cake, or 3 people each have a cake. So if we look at the pictures, Ruiz ate 1/3 of his cake. So his cake is divided into 3 equal pieces. He ate 1/3. Okay, so this third is gone. Liam had the same cake, but his cake was divided into 1, 2, 3, 4, 5, 6 equal pieces. He ate 2/6 of his cake, And then Noah's cake was divided into 9 equal pieces. He ate 3 of the 9 pieces. So when you look at how much of the cake is gone, it's the same amount from each cake. Even though it sounds like Noah ate more because he ate 3 pieces, but his pieces were smaller. So the cake was divided into more pieces, but the pieces were smaller. So the boys, question which boy ate the most, neither one of them. They ate the same amount. So 1/3 is the same thing as 2/6, which is the same thing as 3/9. It's just that the cake was cut differently into more pieces, and the pieces were smaller. Same thing with a chocolate bar. So in this illustration, we have 2/4, 8/16, 4/8, and 16/32s, which are all the same. So if you look at the chocolate bar, it is identical. So the first time, it's 2/4, so there's 4 pieces, 1, 2, 3, 4. There's 2/4 for you and 2/4 for me. That's the whole bar. The next one, we've broken it into or cut it into smaller pieces. So this time we've got 8/16 for you, 8/16 for me. Same thing as 2/4. If we put them together, we would have the same amount. The next one, the pieces are bigger, 4/8, 4/8. Again, same amount. And then the last one, 16/32s. So the chocolate bar has been broken into all the little individual squares, but it's still the same amount. So basically, you're getting half of the chocolate bar. It's just that the pieces that the chocolate bar is broken into are smaller. So they all represent a half. Okay, so how to find equivalent fractions. So we know what equivalent fractions are. They're fractions that have different numerators and denominators, but they represent the same amount. But how do you find them? So to make an equivalent fraction, or to find one, you multiply the numerator and the denominator of a fraction by the same whole number. So as long as you multiply the top and the bottom by the same number, then you're not changing the actual value of the fraction, but you're creating an equivalent fraction. So in this example here, 3/4 is the fraction that we're starting with, but then we're going to multiply the numerator and the denominator by the same numbers. So 3/4, and we're multiplying by 2 halves. So 3 times 2 is 6, 4 times 2 is 8. Then we're going to multiply by 3/3. So top and bottom need to be multiplied by the same value. 3 times 3 is 9, 4 times 3 is 12. Then we're going to multiply by 4/4, 5/5, 6/6. So top and bottom multiplied by the same value. So we end up with equivalent fractions. So 6/8, 9/12, 12/16, 15/20, and 18/24 are all equivalent fractions. Okay, so now we know how to make equivalent fractions. So usually when we're making equivalent fractions, like I said, we're multiplying by the same number, so our numbers are getting bigger, but the value is staying the same. That might be a little bit tricky to understand, but the value, the size is the same, even though the numbers are getting bigger. So when we are adding and subtracting, multiplying, dividing fractions, for our answer, we need to make sure that we reduce fractions to lowest terms. So that means get them as small as we can. So in the what we did here, 3/4 is, let's go down here actually, 3/4 is what we call lowest terms. Okay, so the fraction is reduced. So when we are multiplying by 2 or whatever, you can see our numbers are getting bigger. So 3, 6, 9, 15, 18. So the numerator is getting bigger and the denominator, 4, 8, 12, 20, 24. They're getting bigger. So if we want to reduce a fraction to lowest terms, we're going to start with the biggest number and we're going to divide to get to the lowest number. So to find equivalent fractions, we multiply. To reduce fractions, we divide. So if we're asked to reduce 30 36ths to lowest term, so back when we were finding equivalent fractions, we multiplied top and bottom by the same number. When we're reducing fractions, we divide top and bottom by the same number. So you're not finding which number divides evenly into both, or to each one, it's what number divides evenly into both. So there's several different ways of doing that. The first method is called common factors. So remember what factors are? Factors are the numbers that we multiply together to get a product. So for example, 35 times 6 is 30. 5 and 6 are factors. 30 is the product. So common factors is, using method number 1, is a slow method, but it's a good method. So do 30 and 36. Share any factors other than 1. Obviously 1 divides into everything. So then we need to list the factors of 30. So the factors are the numbers that we multiply to get 30. So 1 and 30, because 1 times 30 equals 30. 2 and 15, because 2 times 15 equals 30. 3 and 10, because 3 times 10 equals 30. And 5 and 6, because 5 times 6 equals 30. Okay, so 1, 2, 3, 5, 6, 10, 15, and 30 are all the factors of 30. Then we list the factors of 36. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6 are 36. So those are all the factors. So now we need to look at, do these two numbers have any factors in common? And we look at them. They have 2, 3, and 6. So those are 3 numbers that 30 and 36 have in common. So now we can use those numbers and divide. We know that 30 and 36 will divide evenly by 2, 3, and 6. So we can start with 2. So 30 times 2 will give me 15, divided by 2. 36 divided by 2 will give me 18. So I have 15 18ths. Now, are we done? We have reduced it. We've divided both by 2. And we've gotten the numbers smaller. So we went from 30 36ths to 15 18ths. But we need to check, can we go any smaller? So now we need to list the factors of 15 and the factors of 18. So the factors of 15 are 1 times 15, 3 times 5. Factors of 18, 1 times 18, 2 times 9, 3 times 6. And they do have one factor in common, 3. So that means we can divide 15 and 18 by 3. 15 divided by 3 is 5. 18 divided by 3 is 6. Do 5 and 6 have any common factors? Well, the factors of 5 are 1 and 5. 1 times 5 is 5. The factors of 6 are 1, 2, 3, and 6. So the only thing they have in common there is 1. Since that's the only thing they have in common, then 5/6 is as low as you can go. That's reduced form, or term, sorry. So that's one way of of reducing a fraction. Another way, the method 2, finding the greatest common factor. So that one we just found the common factors. This way you're going to find the greatest common factor. So same problem, 30 36ths. And the factors we already listed of 30 are 1, 2, 3, 5, 6, 10, 12, or 15, sorry. 36, 1, 2, 3, 4, 6, 9, 12, 18. So the last time, so our common factors are 2, 3, and 6. So the last time we divided by 2. So this time we're going to divide by the biggest number that they have in common, which is 6. So that's the greatest common factor. So we're going to divide 30 by 6, and we're going to divide 36 by 6. 30 divided by 6 is 5. 36 divided by 6 is 6. And there we have 5/6 right away. We only need to divide once. Okay, so this time we only took one step to get our fraction reduced. So that's the more efficient way. It's the faster way. And then we have method 3, which is finding prime factors. This is an even more efficient method. So this, to do it this way, we break the numerator and denominator down into their prime factors. So prime factors are the numbers that are only divisible by themselves and 1, basically. And remove every prime factor the two have in common. So 30, 36. So the prime factors of 30 are 2 times 3 times 5. 2 times 3 is 6. 6 times 5 will give you 30. The prime factors of 36 are 2 times 2 times 3 times 3. So 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. So now we have the factors of 30, which are 2 times 3 times 5, and the factors of 36, 2 times 2 times 3. So now what we do is we cross out the ones they have in common. So we cross out 1, 2, we cross out 1, 3. We're left with 5 and 2 times 3, which is 6. So 5 sixths. So again, another way of finding, of reducing a fraction. Okay, so some tips and tricks for reducing fractions. I mean, you always find little tips and tricks that help you reduce fractions. So here's a few. Okay, so first of all, if either numerator or denominator is a fraction is a prime number, then the fraction cannot be simplified further. So a prime number, as I said, means that the only thing that will divide by that number is 1 and itself. So for example, the number 7. To get 7, all you do is multiply 7 times 1. There's nothing else. 3 times 4 will give you 12. 1 times 2 will give you 2. 1 times 3 will give you 3. 2 times 3 will give you 6. There's nothing else that we can multiply to get 7. So that is a prime number. So if you have a fraction that has a 7 in it, unless the denominator or the numerator is divisible by 7, you can't reduce it any further. A fraction that has 1 in the numerator also cannot be reduced further. Like I said, that's called a unit fraction, and you can't go any lower than 1. To reduce an improper fraction, first write it as a mixed fraction and then follow the method of simplifying the proper fraction. So if you have, for example, 3 and 4/8, oh, sorry, that's not right. I'm thinking about it. If you have an improper fraction, so let's say 24/5, you have to change that improper fraction to a mixed fraction first. So 5 4s will give me 20 and 4/5. So 4 and 5/5, sorry, is my mixed fraction. So then once I get there, I can't reduce the 4 because that's a whole number. You can't reduce a whole number. So then I just focus on the fraction. Okay, so that's the way you reduce if you have an improper fraction. Number 4, for finding factors of numbers in the range of 1 to 120, so any number that's between 1 and 120, you can just check if they're divisible by 2, 3, 5, and 7. So in the example, 24/73, 2 will divide evenly into 24, but not in 73. So that means you can't divide by 2. 3 divides into 24, but not into 73. So you can't divide by 3. 5 doesn't go into either. Finally, 7 doesn't go into 24. So that means that that fraction, 24/73, is already in lowest terms. 73 is actually a prime number, so you can't reduce it any further anyway. The reason for this is if any number from 1 to 120 factors as m times n, then the smaller of m and n must be less than 11. So otherwise the number would be at least 11 times 11, which is 121, so that's more than 120. So if the number is composite, made up of smaller numbers. The smallest factor must be a prime less than 11. So the prime numbers that are less than 11 are 2, 3, 5, or 7. Checking divisibility by 2 and 5 is easy, so start with those. To check 3, you can add up the digits and see if that's divisible by 3. For example, 123 is divisible by 3 since 1 plus 2 plus 3 equals 6, and 6 is divisible by 3. Divisibility by 7 is harder to check, but you could use long division and see if you get a remainder. 73 is 3 more than 70, so the remainder here would be 3. Okay, so that's a little bit complicated, but it is a method that can work if you can practice it enough to get it. Okay, there's another hack for simplifying big numbers like 96 104ths. So first, subtract to get the difference between numerator and denominator. So 96 over 104, subtract the numerator from the denominator. So 104 take away 96 equals 8. So the difference, 8, is the upper limit for any numbers that can possibly divide into both the 96 and 104. No number larger than 8 can go into both. In other words, the difference is the largest possible greatest common factor. So remember the method we learned about dividing by the greatest common factor? This is a method for finding this. Second, does 8 go into both 96 and 104? Well, 96 divided by 8 is 12, and 104 divided by 8 is 13. So then third, state the answer. 96, I'm just going to write it this way, 104th is equal to 12/13. Okay, what about 74/80ths? So again, subtract, denominator take away numerator, 80 take away 74 is 6. So 6 is the largest number that can possibly go into 74 and 80. So now you got to ask yourself, does 6 divide evenly into both 74 and 80? No. In fact, it goes into neither number. So if you divide 80 by 6, you will get a decimal. Same thing, 74 divided by 6 will give you a decimal. So even though 6 does not go into 74 or 80, it tells us that the only numbers that can possibly go into both 74 and 80 are the factors of 6. So 6, 3, and 2, we know 6 won't go, so we try 3 and 2. So now try the next largest factor of 6, which is 3. So divide by 3. So 3 won't go into either 74 or 80, won't go into neither 74 nor 80. So now we've ruled out 3. The last one left is 2. So try 2. 74 divided by 2 is 37. 80 divided by 2 is 40. So then your answer is 37/40. And you do sometimes get big numbers for your answer, and that's okay. Okay, so let's do some practice with reducing fractions. So what happens when, whoops, how do we get down there? We need to be up here. Okay, so simplify the fraction, 6/30. So one thing I always look for when simplifying fractions is to see if the numerator, so the number on the top, will divide evenly into the bottom. So 30 divided by 6. Does 30 divide by 6? Yes, it does. 30 divided by 6 is 5. And I know 6 will divide by 6. So I divide numerator and denominator by 6. 6 divided by 6 is 1. 30 divided by 6 is 5. Now I've got my 1 in my numerator, so that's as low as it will go. Number 2, 5/10. Again, will 5 divide evenly into 10? Yes, it will. So I'm going to divide top and bottom by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. Okay, so this way you are using the greatest common factor because you can't divide 6 by anything bigger than it. Number 3, 4/40ths. So will 4 divide evenly into 40? It will, because 40 divided by 4 will give me 10. So then I divide 4 by 4, which will give me 1 and 10. So 1/10. Number 4, 24/30ths. So 24 won't divide evenly into 30. It's almost as big as 30, so I know it won't divide evenly. So now I need to come up with a number that will divide evenly into 24 and 30. Now I can start dividing by 2. Okay, so this is just finding a common factor. 24 divided by 2 will give me 12. 30 divided by 2 will give me 15. So I've got 12 fifteenths. Now, can I divide anything into 12 and 15? Well, I know 3 will divide into 12 and 3 will divide into 15. 12 divided by 3 is 4. 15 divided by 3 is 5. And now I know I can't go any lower than 4/5. So I can do it that way. Okay, another way I could do it is the one method we just talked about. 30 take away 24 will leave me with 6. So I can do it divide this way. So 24 divided by 6 over 30 divided by 6. 24 divided by 6 is 4. 30 divided by 6 is 5. And so I get my answer fairly quickly. Okay, number 5, 6/8. I know 6 won't divide evenly into 8, so I can think of what I can divide by. 6 is 2 times 3. 8 is 2 times 4. They both are divisible by 2, so I'll divide both by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. And I can't go any lower than 3/4 because 3 is a prime number. 8/12. 8 will not divide evenly into 12, so I need to figure out what will. 8 is 2 times 4. 12 is 3 times 4, so I know they both are divisible by 4. So 8 divided by 4 over 12 divided by 4. 8 divided by 4 is 2. 12 divided by 4 is 3, and that's as low as it can go because, again, 3 is a prime number. 24/12. Will 12 divide evenly into 24? Yes, it will. So I can divide both by 12. 12 divided by 12 is 1. 24 divided by 12 is 2. Very easy. Okay, number 8, 99 108ths. Well, I know that 99 won't divide into 108. It's almost 108 as it is. So this is another one where I'm going to do this little trick subtraction. So 108 take away 99. 108 take away 99 equals 9. So now can I divide both by 9? So 99 divided by 9. 99 divided by 9 will give me 11. 11 times 9 is 99. 108 divided by 9 is 12. So I have 11/12. Okay, let's try. Let's go over here and do number 12. 63/72. So I know that that's not going to divide 63 into 72. So I'm going to do 72 take away 63, which is 9. And then will 9 divide evenly into 63 and 72? 63 divided by 9. 9 times 7 is 63, and 9 times 8 is 72. So 7/8. Okay, so there's lots of tricks to helping you get it. Okay, so now what happens when you have to reduce a mixed number or a mixed fraction? So what you do is you don't change anything. What you do when you have to reduce a mixed number or mixed fraction is you don't do anything with the whole number. The whole number is untouchable. The only thing you're reducing is the fraction part. So just leave your 1, your whole number, and reduce the fraction. So 2 will divide by 2, and 6 will divide by 2, so that 2 divided by 2 is 1, 6 divided by 2 is 3. So my answer is not 1/3, my answer is 1 1/3. You have to bring that whole number down. Okay, so 2 and 3/45. I'm not doing anything with that 2. I'm just going to leave it for now. I'm going to reduce the fraction. So I know 3 will divide by 3, and 45 will also divide by 3. 3 divided by 3 is 1, 45 divided by 3 is 15. So my answer, now I bring down that 2, is 2 and 1/15. Okay, oops. Next one, number 4, 4 and 24/34. Again, I'm going to leave that 4 alone, but I'm going to reduce 24/34. So what will divide into 24 and 34? 12 will divide into 24, but it won't divide into 34. Let's just go with 2. Divide by both by 2. 24 divided by 2 is 12. 34 divided by 2 is 17. So 12/17. And then I bring down the 4. So my answer is 4 and 12/17. Okay, so that's how you do it with mixed fractions. Okay, so that brings us to key question 6, reduce the fractions to lowest terms. So again, take your time with those. E and F are mixed fractions, so leave the whole numbers alone, reduce the fractions only. Okay, don't try to do anything with the whole numbers, but then include the whole numbers in your answer. All right, so that is it for our class today. When we meet again next week on Tuesday in our regular scheduled time, we'll continue on and we'll start with adding and subtracting fractions. So